Welcome to solverfy.
In this problem, we are given a system that a block suspended from a spring. The spring constant is 75 pounds per foot. The block weighs 7 pounds. The excitation, the support is that of the support that is attached to the opposite side of the spring. So we have our support, our spring, and our block. And this thing is moving up and down. And that motion has an amplitude of 0.15 feet and a frequency of 2 radians per second. And they want us to determine the phase angle of the force vibration. Well, we can do that quickly just by looking up the formulas in the book. So we can first find the natural frequency, converting the weight to a mass, and that turns out to be 18.6 radians per second. So you can see that we're very well below the natural frequency here. We can also figure out the, they told us actually that the damping ratio, or the level of damping compared to the critical damping, and I've always used the symbol, if you take a class of vibrations, you'll call that zeta. And so zeta is 0.8, which is actually a lot of damping, a very highly damped system. Not over damped, but again, this thing is going to decay very fast. In fact, it'll probably maybe go under one oscillation, and maybe even you can barely see the oscillation before it decays practically to zero. Anyway, we can find the phase of the response, which is basically how the shift in time from the response to from the excitation to the response. And that is the inverse tangent of 2 zeta r over 1 minus r squared, where again, r equals the forcing frequency divided by the natural frequency. We can calculate that because we have everything, and we actually, in this problem, we don't even use this. So we can plug everything in, take the inverse tangent, and again, be a little careful about the sign, because this thing will always be positive, but this thing could be positive or negative. So we want to make sure we're in the correct quadrant. In this case, we wind up with an answer of 9.89 degrees, and that's in the first quadrant, and that was what we would expect because r is much less than 1. So this is positive, this is positive. So our tangent, our angle should be somewhere in this first quadrant. So again, you just got to be careful when you're taking inverse tangents on your calculator to make sure you get it into the right quadrant.